Okay, so today we're going to be talking. Oh, I just realized I'm wearing a mask still. Okay, let me take that off. Okay, sorry about that. Okay, so today we're going to be talking about graphing for systems of linear equations. So systems means there are two equations, at least two, on our graph, basically. And again, these are linear equations. So again, we're following the same slope-intercept linear equation formula, which is y equals mx plus b, where m is the slope and b is the y-intercept. Okay. So our goal here with systems of equations is to actually find the point where two lines intersect. That's our solution. We actually have a solution this time. Normally when we graph linear equations, we just have the line as our answer, right? This time our solution is going to be the ordered pair or the point where those two lines intersect. So let's look at an example. So starting on number 2 here, and let me zoom in here a little bit so we can see more clearly what I'm doing. Okay, so looking at this problem, let's start with the first equation. So again, there are two different equations. You just graph them individually. So don't get hung up that there's two. You can ignore the second equation for now and just focus on that first equation. The first one has a slope of -3 and a y-intercept of -4. So again, to graph that, I would start at the y-intercept, so start at -4, and then I plot out my slope. And again, it's rise over run for the slope. So if it's -3, that's the same thing as -3 over 1. The -3 is what's happening up and down. The 1 is what's happening left and right. Okay, so that means I could go down 3 and right 1. That's off my graph. So then I have to go back the other direction, right? So if I have to go up 3, that means I have to go left 1. And it should form a negative slope, right? Because it's a negative line, so it should be going downhill from left to right. And you can do that a few times. Up 3, 1, 2, 3, over 1, up 3 over 1. And you end up with a line that looks something like that. Okay? Then we're going to do the same thing with the other equation. So we're just going to graph the other equation. And it's y equals 2. Y equals 2, there's no x there, so it's one of our special cases. Y equals 2 is that horizontal line, right? That means y is always 2. If y is always 2, look at all these points that have a y value of 2. If we connect all of them, we get a horizontal line right there. But again, our whole point of doing this is to figure out that point where those two lines intersect. And they intersect right there. And that, in our solution or answer, is that ordered pair where those two lines intersect. And it's intersecting a -2 on the x and +2 on the y. So the ordered pair would be -2, 2. Because again, ordered pairs are always written as the x-coordinate first and then the y-coordinate. So -2, 2 would be that point right there on your graph. And that is where those two lines cross or intersect. That's the only point that those two lines will ever hit each other. So that would be my solution. Okay, not too tough, right? Let's look at another example. So this one, again, let's start with the first equation, has a y-intercept of -1, so I'd start at -1, and a slope of 3 over 4. So again, 3 over 4, that is going up or down 3 and left or right 4. So it's positive, so it should be going uphill, right? It should be going uphill as we go from left to right. So with positive slopes, you can go two positive directions, so I can go up and to the right. So I can go up 3, 1, 2, 3, to the right 4, 1, 2, 3, 4. Or I can go two negative directions, because -3 over 4, -4, is the same thing as +3 over +4, right? Because those negatives would cancel out. So if I go down 3, 1, 2, 3, and left 4, look, it's on the same line, right? That would be my line for that first equation. Okay, the second equation, x equals -4, that's the other special case. It only has the x, so it is a vertical line, right? If all the x values are equal to -4, look at all these points that have an x value of -4. All those points have an x value of -4. So if we connect all those, we get a vertical line. And then again, we're looking for the point where they intersect. And they are intersecting right there at -4 and -4. So my solution would be -4, -4. Just the ordered pair that represents that point. Okay? Let's do a couple more examples here. So let's do number 6 here. So this one, let's graph it. So this first one starts at 1, right? So starts at 1, and then the slope is 5, or 5/1. So it's positive, so I can go up 5/1, but that's off the graph. So then I have to do the -5/-1, the other directions. Because again, those are the same as positive, because those negatives cancel out. So I could go down 5, left 1, and there's an ordered pair right there. And this is kind of a steep line, and I only have 2 points. I'm going to use a ruler just to make sure I get a good line here. Okay, so there's my first line. And then the next equation, the y-intercept is -3. And then I could go up 5 and over 1, because it's got a 5/1 slope as well. So if I go up 5/1, and I can't go down 5 left 1 because that's off the graph. So those are the only 2 points that fit. So if I connect those 2 points, let's see. I get that line. Now these lines don't touch. Did I do something wrong? No. I did everything right, but these have the same slope, right? Which means they're increasing at the same rate. So if they aren't started in the same spots, they're never going to touch. These are what you call parallel lines. Parallel lines never touch. Any line that has the same slope is going to be parallel. Okay? Because if the rate in which it's going up and over is the exact same, then it's going to be a parallel line. Now the problem here is if there's no solution here, right? They never touch. And that's exactly what my solution is no solution. Because these lines will never touch. Ever. So they will never share the same point, so there is no solution. Why is it sad that parallel lines have so much in common? Because they'll never meet. Yes, go ahead and roll your eyes. Okay. One more example, and then I'll let you guys work. So, last one. Y-intercept of 1. So I start at 1, and the slope is -2/3. So negative slopes, one positive, one negative direction. So if I go down 2, I'd have to go right 3. Down is a negative direction, right is a positive direction. If I go up 2, I'd have to go left 3. Up is a positive direction, left is a negative direction. And that would be the line that would form, that would be the line that would form. I went too far over. And I can't erase it because it's pen. Don't use pen, kids. Can't erase. Do what I say, not what I do. Okay, and then the last example, or the last problem here, -3 is my y-intercept, and my slope is -2, or -2/1, right? So I could go down 2, right 1, or I could go up 2, left 1. And I can do that a couple of times. Up 2, left 1, up 2, left 1, up 2, left 1. What did I do wrong here? Started at 1, down 2/3, up 2, left 3. Should hit out right here is the other point. Okay, sorry, had to talk myself through it. That is the line. I made a couple mistakes on that one. Maybe I shouldn't have done this example. So it's hard to see, but this point right here is what Sorry, guys. This is why you don't use pen. This point right here at -3 and 3 is the point where they intersect. So the point where they intersect is -3 and +3. And that would be your answer. Okay. So again, you're looking for the point where they intersect. If they don't intersect, if they are parallel lines, then you write no solution. Okay. If you have any questions or concerns, ask your teacher. We're here to help. We want to help. And we'll see you guys out there.